Hello everyone. In this session we will going to learn the testing of transformer. There are various types of testing of transformer. These are routine test, type test, supplementary test and the special test. In this tutorial we will going to learn the routine test. Let's see what is the routine test. The routine tests are those tests which are conducted on each and every transformer manufactured in a industry, or it can be defined as follows. A routine test of a transformer is mainly for confirming operational performance of an individual unit in a production lot. All the transformers are subjected to the following routine test. There are these some types of tests which are conducted on the transformer, which comes under the category of routine test. Out of that, we will focus on the polarity test of the transformer. Let's see what is the polarity test and what is the polarity. Polarity means the direction of the induced voltage in the primary and the secondary winding of the transformer. Basically, there are two types of polarity. That's our additive type of polarity and second one is subtractive type of polarity. Let's see what is the additive polarity. In additive polarity, the same terminal of the primary and the secondary winding of the transformer are connected. Let's see one simplest example of the additive polarity. There is a one circuit where two voltage sources are connected in series with one voltmeter. Let's consider the first voltage source having value 5 volt and second voltage source having value 5 volt. As per the basic, we know the direction of the voltage source. That is, this one is the negative terminal, this one is the positive, this one is the negative and this one is the positive terminal. The direction of current is always from positive terminal of the battery to the negative terminal of the battery. So, here current flow in this direction. Voltmeter V reads the value of these voltages. As the voltage source are connected in a same manner, this voltmeter reads V1 plus V2, that is equal to 10 volt. So, this circuit is having additive polarity. Let's see the second one, which is the subtractive polarity. In subtractive polarity, different terminal of the primary and the secondary side of the transformer are connected. Let's see again simplest example of the subtractive polarity. Here again the two voltage source are connected in series with one voltmeter. These two voltage source are connected in a opposite fashion. That means as per the basic we know the direction of voltage source. Here again the current flow in a positive terminal of the battery to the negative terminal of the battery. But as they are connected in opposite fashion, the voltmeter reads the subtraction of this voltage source. Consider the voltage source V1 having the value 5 volt and second voltage source having the value 5 volt. Then voltmeter reads V1 minus V2, that is equal to 0 volt. So this circuit having the subtractive polarity. Why we do the polarity test for the transformer? After all, a transformer is nothing but more than a set of magnetically linked inductor. An inductor don't usually come with the polarity marking of any kind. If we were to look up this unmarked transformer, there is a no polarity marking. So we can consider any kind of polarity to its primary and secondary side. So there is a one practical concern is come. Transformer manufacturer have come up with a sort of polarity marking standard to denote phase relationship. It is called as the dot convention. It is very easy with the dot convention to know the polarity of the transformer. So let's see the dot convention of a two-winding transformer. Here there is a figure 1. The dot convention appearing at the one end of both the winding tells the polarity of voltage and current of the whole transformer. If the primary voltage is positive at the dotted end with respect to undotted end, then the secondary voltage will be positive at the dotted end with respect to the unmarked end. Same way, in the second diagram, if the primary voltage is positive at the dotted end with respect to unmarked end, then the secondary voltage will be positive at the dotted end with respect to undotted end. In both the diagram, the dot represents the direction of voltage or the polarity of the voltage. Again, let's see one example to show the direction of the current. In this diagram, the current primary, that is IP, flowing into the dotted end, whereas the secondary current will flow out to the dotted end of the secondary winding. Same way, in the second diagram, the current primary entered into the dotted end and the secondary current will flow out to the dotted end of the secondary winding. In both the diagram, the current relationship is shown. In the first diagram, both the current IP and IS are in phase with each other, whereas in second diagram, current IP and current IS are out of phase with each other. Thank you for watching this video.